have lost count of the number of comments asking me to do a video on mixture questions, so here it is. And this is what a typical mixture question will look like. It says, 2 brands of detergent are to be combined, mixed. Detergent X contains 20% bleach and 80% soap, while detergent Y contains 45% bleach and 55% soap. If the combined mixture is to be 35% bleach, what percent of the final mixture should be detergent X? And I can picture hundreds of students right now getting really stressed because they don't like mixture questions. So what's my amazing method for this? First, what ingredient are they focusing on? Which ingredient did they give us a middle number for, a mixed average for? It was bleach. They told us that when we mix them together in the final sentence, the combined mixture is to be 35% bleach. So we need to focus on bleach here to solve this question. Don't worry about soap for now. Okay, so we're focused on bleach. We've got detergent X being 20% bleach and detergent Y being 45% bleach. What do? This is the method. You draw essentially like a number line or just a horizontal line on the page. On the left, you put the smaller amount. That was 20% bleach, detergent X. On the right, you put the higher amount. That was detergent Y, 45% bleach. Notice I didn't write anything to do with soap. Why? Because we're focusing on the bleach. They told us the combined mixture is to be 35% bleach. So that's what I focus on, the bleach ingredient only. What else do we do with this magical line? We put in the middle the mixture, which is 35% bleach. So anywhere on the middle of that line, you can just write 35% representing the mixture. The fancy term would be the weighted average being 35% bleach. Now what do? I can hear you ask. On the left of this line, we write down the distance between 20 and 35. By the way, if any of this is scary, I'm going to be doing loads of examples, so get strapped in. Look at the difference between 20 on the left and 35 in the middle. That's a difference of 15. Notice I don't even bother writing percent. The percent symbol doesn't matter here, just the distance of 20 to 35 being 15. What's the distance between 35 and 45? That's 10. And now what do with these two distances? We invert them, meaning we put the 10 across to the left and we put the 15 across to the right. Now, many of you will be thinking, okay, but why do we do that? I trust Philip. I know this method is going to work. He's an amazing tutor, thank you. But why do we do this? The reason we do this, the short version of the reason, I'm only going to give 20 seconds on it, is that the distances are inversely proportional to the weight of the average, meaning the further the distance, the less of that ingredient. Because 20 is further from 35 than 45 is, it actually contributes less to the overall total. There must have been less of detergent X. And that distance being bigger, that 15 being bigger, therefore inverts across. The bigger number belongs with Y because there must have been more of Y. The smaller distance, 10, should belong on X's side because there must have been less of X. That's the 30-second version of the reason why. If enough people ask me, I can go into more detail. But for now, you can just remember that the two distances flip across diagonally. So the 10 is now on the left and the 15 is now on the right. That becomes a ratio. So don't forget the colon in the middle. And of course, like any ratio, we want to simplify it. If it was decimals, for example, we'd multiply both sides by 10 to get rid of the decimal. Here we have integers, so let's just simplify by dividing by 5, giving us the key ratio of 2 to 3. That actually answers almost any question they can ask for a mixture question. And I'm going to prove that with loads of examples in a second. We have found the ratio between X and Y. For every 2 of X, detergent X, there must have been 3 of detergent Y. That's why that middle number, the 35%, is closer to the 45 than it is to the 20. And that's my amazing secret for mixture questions. Now, how do we actually finish the question? What percent of the final mixture should be detergent X? They weren't asking for a ratio, I hear you say. They were asking for a percentage. Well, we can easily convert a ratio into a fraction or a percentage, as I demonstrate here. What do? We add up the ratio. So 2 plus 3 is 5. Notice the ratio at the bottom, 2 to 3. You add it up. 2 plus 3 is 5. And then you get 2 fractions. On the left, we have 2 out of 5. That's X. On the right, we have 3 out of 5. That's Y. Therefore, detergent X is 2/5, or 2 out of 5, of the total. And 2/5 you can either know off by heart, preferably, or use a calculator. Can tell you 2 divided by 5 times 100 is 40%. So 40% of the mixture, answer D, has to be detergent X, of course, meaning that 60% of the mixture is detergent Y. And that is my amazing method in a nutshell. Before we move on, notice one key ingredient to getting this question right. We noticed a middle number between 2 other numbers. We noticed that combined mixture was 35% bleach, and that 35 is in the middle of the 20% bleach and 45% bleach. So that's how I remember to use this method if I see a middle number between 2 other numbers. Okay, but what about in a question such as this one, when there's no obvious middle number? How do we do this type of mixture question? I'll give you time to read it. If you really want to, you can try it, but I'm going to be explaining how to do it. Then after this, I'm just going to open up a website that's got I think 10 mixture questions. I'm just going to do them quickly to prove how this method works, even under the stress of time pressure. Anyway, this question. A scientist needs a 10% saline solution, that means salt solution, for an experiment. In his closet, he finds a 20-ounce bottle of 25% saline solution. How many ounces of pure water should he add to the mixture to produce the correct saline solution? I know what you're thinking. No middle number. We're going to have to do some long, complex algebraic equation. No, there is a middle number. He wants 10% saline solution. What he's got is 25% saline solution, and then he's going to add water. But if it's pure water, what percent of pure water is salt? 0%. So if he's adding pure water, he's basically mixing in 0% salt. And that was the hidden aspect of this question that they were hoping you didn't spot. So we have the number line again, our favorite method. We have 0 on the left, that's the pure water, that's 0% salt. On the right, we have his 20-ounce bottle of 25% saline solution. And our goal is to end up with 10% saline solution. That's in the middle. There's our middle number between 2 extremes. You notice I've snuck this trick in no matter what the mixture question is. Okay, let's follow our method, see if you remember. If you want, you can pause and finish it off yourself now using my method. First, we find the distance on the left, that's 10. Don't worry about the percent symbol. Then the distance on the right, that's 15. Happens to be the same numbers as last question, just reversed. So we reverse the numbers. 15 goes to the left, 10 goes to the right, giving us a ratio of 15 to 10, which we can simplify to 3 to 2. That's our key ratio. But at this moment, I'd like for you to pause and think. This is when our method gives us the correct answer. But it's up to us to use that correct answer to finish off the problem. We know the ratio of water to bottle is 3 to 2. But sometimes, like in the last question, we have a total, and so it makes sense to add up the ratio and find a fraction. But here we don't have a total. We just know one more fact about the situation. The one more fact, can you spot it, that we know about the situation? We know the fact that it was a 20-ounce bottle of 25% saline solution. So we know we had 20 ounces of the bottle. Can you use that ratio 3 to 2 to tell me therefore how much water he must have had? Well, if he had 20 ounces in his bottle, and that's the 2 side of the ratio, then the 3 side of the ratio must be 30 ounces for the water, giving us the ratio 3 to 2, 30 to 20. If you were not sure how to get the 30 there, you could notice that 2 times 10 gets us to 20, and therefore 3 times 10 gets us to the 30, finding the multiple between the ratio and the actual amount. Anyway, I picked this example to demonstrate 2 things. First, even when it doesn't look like we've got a middle number, sometimes the middle number is there in disguise. For example, pure water is 0% saline, so there's our middle number, 0, 10, 25. And second of all, and that's why I highlighted it in blue, my method gives you the ratio between the 2 quantities. It's up to you to then finish the question. Maybe the question will be asking you for a ratio, in which case, great, we've got the answer. Maybe it asks you for a percentage, like the last question. Great, we convert the ratio into a percentage by adding it up, making it a fraction, and then using a calculator, for example. Other times, like in this question, we need to use the ratio knowing one of the sides of the ratio. So we had the ratio here 3 to 2, and we knew that one of the sides, the bottle side, was 20. So we found the multiplier. To get from 2 to 20, we times by 10. So we do that to both sides of the ratio. So there are many ways they can end the question, but only one method to get you there, in my opinion. Well, the best method anyway. Okay, I'm going to now bring up that website with loads of questions. And I could have finished the video here, but I want to blitz through a load of questions just to demonstrate that this method may seem quite complicated, but it gets really easy once you're used to it. So I'm going to flip across to that screen, link in the description, and get my OneNote out and get started. If you excuse the mess, I'm going to be drawing straight on the screen. Okay, here. Feel free, by the way, of course, to pause and answer it yourself first. Mixture A is 15% alcohol, and mixture B is 50% alcohol. If the two are poured together to create a 4-gallon mixture that contains 30% alcohol, approximately how many gallons of mixture A are in the mixture? The gap between 15 and 30 is 15. The gap between 30 and 50 is 20. Flip those across and you have the ratio 20 to 15, which simplifies down if we divide by 5 into 4 to 3. And if there are 4 gallons in total, we need to break down that total using this ratio. 4 plus 3 equals 7. So the two fractions are 4/7 of it is mixture A and 3/7 is mixture B. Now, I may need a calculator here, but mixture A is 4/7 of 4. I'll quickly use an off-screen calculator to work that out. But 4 divided by 7 times by 4 gives us 2.29 gallons was mixture A. And it's done. That's it. Underlining here the word approximately, of course, we would round this, but that's the answer. Okay, let's do the next one. A chemist needs to mix a 10% acid solution with a 35% acid solution and end up with 1,000 milliliters of 25% acid. So that's the middle number. How much of each solution is needed? The gap on the left is 15. The gap on the right is 10. Flipping those across, we have the ratio 10 to 15. Obviously, I'm rushing a bit, so it's not the most elegant diagram. There's no line, etc. But I think you'll excuse that just to show you loads of examples. Giving us the ratio 2 to 3. Breaking down 1,000 in the ratio 2 to 3. I think I can do that in my head. 2 plus 3 is 5. So we have the two fractions 2/5 and 3/5. 2/5 of 1,000 is 400. So we have 400 of the 10% and 600 of the 35%. And we're done. Okay, next one. We have 3 litres of 40% orange juice and 1 litre of 50% orange juice are mixed. Which of the following is the percentage of orange juice in the mixture? Okay, so we need to find the middle number here. It's slightly different to the other examples. We need to find the middle number, but they're telling us the ratio. They're telling us that the ratio is 3 litres of 40% to 1 litre of 50%. Your job is to go back in time in the method to work out what the actual middle number is. What is the overall percentage of orange juice? Can you use our same method but in reverse order to find that middle number? Well, let's draw our number line. We know the ratio is 3 to 1 between the 40% and the 50%. Going backwards, therefore, the gap on the left must be 1 and the gap on the right must be 3. This is fun. Now, how do we use that to find the middle number? We know the gap is 1 on the left and the gap is 3 on the right, but that only adds up to 4. 1 and 3, the two gaps, only add up to 4. If you think of that, 1 plus 3 is 4, and yet the actual gap is 10. That doesn't make sense. The actual gap between 40 and 50 is 10. If the actual gap is 10, what do we have to multiply 4 by to get the actual gap of 10? 4 times what gets you to 10? 4 times 2.5. So the actual gap, when you could do 10 divided by 4 if you didn't know that, the actual gap on each side must be 2.5 times bigger. 1 times 2.5 is 2.5, and 3 times 2.5 is 7.5. So I'm really glad that this question came up actually, because it shows you how to do the method if they ask it in reverse order. They gave us the two sides, 40 and 50, but they didn't give us a middle number. They instead told us the ratio. So what did we do? We got the ratio, 3 to 1. We inverted it to find the gap. But then the gaps, the 1 and 3, didn't add up to 10. How did we solve that? We scaled it up. 1 and 3 don't add up to 10. They add up to 4. So scaling up 4 to reach the 10, you had to multiply by 2.5. So we multiplied the 1 by 2.5 and the 3 by 2.5. So what's that magic mystery middle number if it's 2.5 away from 40 and 7.5 away from 50? It must be, of course, 42.5. You just add on the 2.5 to the 40, or you take away 7.5 from the 50. So that was a bit more complicated. That was a higher level question, but we use the same method in reverse order. Okay, let's do the next one. I might do all of them and then come back to the answers actually. In fact, you know what? I don't even need to go back to the answers because I know this method works and he's giving us the right answers. Okay, one liquid solution of 7 litres contains 40% water. Another solution contains 20% water. So we've got the 20 on the left and the 40 on the right. If these two solutions are mixed, what percent of the mixture is water? Well, brilliant opportunity for you to try the exact same method again. Same situation, we don't have the middle number, but we do have the ratio. Can you finish it off? Pause and try along if you want. Okay, so we know we've got 7 of the 40 and 18 of the 20. That's the ratio, of course, 18 to 7. Flipping that, it gives us the distance. 7 on the left, 18 on the right. But wait, 7 and 18 don't add up to the gap of 20. What do 7 and 18 add up to? 7 plus 18 is, of course, 25. So this time we actually have to scale it down a little bit because the real gap is 20. Or in other words, what do we have to multiply the 25 by to get to 20? We're scaling it down. Well, I know in my head that's 0.8, but if you didn't know that, you could do 20 divided by 25. Just like we did 10 divided by 4 to get 2.5. You do 20, which is the actual gap, divided by 25 to find the scale factor of 0.8. I can do these in my head actually. 7 times 0.8 is 5.6. So the actual gap on the left is 5.6. And 18 times 0.8, see if I can do that in my head, 14.4. So those are the two actual gaps, leaving us a middle number of 25.6. So that's the overall percentage that is water. Now, these are quite high level questions, much higher than typical that you'd see in the exam. But those students who've made it this far, I know are the dedicated students who really want to try the toughest questions. So let's keep going. Dr. TikTok needs to make a solution that is 60% alcohol. She has 4 litres of 25%. So on the left, we've got 25%. How many of the 80% solution will she add? So on the right, you've got 80%, and she needs it to be 60%. Okay, we're back to the more standard questions. Well, the gap on the left is 35. The gap on the right is 20. Moving those across, we have 20 to 35, which if we divide by 5 gives us 4 to 7. And they've told us that we have 4 litres of the 25% one. Oh, well, that's perfect. If we have 4 litres of the 25% one, we must have 7 litres of the 80% one. Okay, next one. I'm not sure I'll do all of these, but I'll keep going while you're interested. A mixture of 12 ounces of vinegar and oil is 40% vinegar by weight. How many ounces of oil must be added to the mixture to produce a new mixture that is only 25% vinegar? This was like my second question. How many ounces of pure oil? Well, oil is 0% vinegar. So we have, let me give myself some space here. I'll erase this. Oil is 0% vinegar, so there's like a hidden number there. We've got oil being the 0%. We've got the original mixture, which was 40% vinegar. And we want a new mixture that is 25% vinegar. Okay, so we have a gap on the left of 25, a gap on the right of 15. Mixing these across, we have 15 to 25, which simplifies down to, if we divide by 5, to 3 to 5. So that's the key ratio I'm always talking about. And we have 12 ounces of the original solution. So we have 12 ounces of that original 40% solution. That means that number 12 belongs on the right. And we have the ratio 3 to 5. So how much oil must there be? The ratio is 3 to 5, and we know there's 12 ounces on the 5 side. Well, I don't know about you, but I go from one side of the ratio to the other side by dividing and then multiplying. So I do 12 divided by 5 times by 3 to get the other side. 12 divided by 5, see if I can do this in my head, that's 2.4 times 3, that's 7.2. There are other ways to do that, but that's my method for getting from one side of a ratio to the other. I divide by that side and then multiply by the other side. So I knew 12 belonged to the 5 side because it was talking about the 12 ounces for the 40%, which is on the right. And so I divided it by 5, times it by 3 to get to the left-hand side. Okay, getting quite tired now, but I'll keep doing some more because I know you're interested. And I've had so many comments over the last couple of years about mixtures. And of course, I have done another video on this called Weighted Averages, which I really would recommend you to check out if you want more practice. But for now, we're just doing pure questions. Oh, there's only 3 left. Why not? Let's just finish it. 2 solutions of 90% and 97% purity are mixed, resulting in 21 litres of a mixture at 94. Okay, so we've got 90 on the left, 94 in the middle. You're getting so bored of this, you know the method so well now probably. The gap on the left is 4, the gap on the right is 3. I just do this instinctively without even looking at the question. So therefore the ratio is 3 to 4, flip it across. Now, what's the actual question? We have 21 litres of the mixture. How much is the quantity of the first solution? So how much is the 90% side? So this is like my first question in the video. We have a total of 21. So what do? How do we use a ratio when we know what the total is? We add up the ratio. So 3 and 4 add up to 7, meaning that the 90% side is 3/7 and the 97% side is 4/7. And the total is of course still 21. But they want to know the 90% side. So they want to know the 3/7 side. What is 3/7 of 21? 21 divided by 7 times 3 is 9. So there's 9 of the 90% side. Okay, 2 more to go. Always the same method, just slightly different applications. Do we do it in reverse or forwards? And how do we use the ratio? Do we convert it into a total, a fraction, or into a percentage? Always the method is the same. Okay, a mixture of 20 litres of brandy and water contains 10% water. How much water should be added to increase the percentage to 25%? Well, where's the middle number? It's 25% because they're adding pure water. And pure water is, of course, 100% water. So all these questions, they often contain a hidden percentage. If something is pure water, it's 100% water. Or if the question was about oil, pure water would be 0% oil. So you do have to use your head sometimes for these harder level 170 questions. The gap on the left is 15. The gap on the right is 75. Flipping that across, 75 to 15. Divide that by 15. Gives us 5 to 1. Okay, and we know that the original 20 litres was the 10%. So the 20 litres belongs on the left. What's the scale factor? To get from 5 to 20, we times by 4. So we do 1 times 4 to get to 4. So there must be 4 litres of pure water. Notice every time I get to this same stage where I have a ratio, and then it's just different endings to the same story. Sometimes we have one of the amounts, like here we had 20 litres on the left, so I found the scale factor. Other times, like in the previous question, I didn't have one of the sides. I didn't know how much 90% or how much 97%. I just knew that the total was 21. So I turned the ratio into a fraction, 3/7, 4/7, and multiplied it by the total. So different endings, but it's the same story every time. I really hope all of these questions helped you to grapple with mixture questions. And I've finally answered thoroughly the comment I always get, which is please do a dedicated video on mixtures. So I do read the comments and I do respond to them eventually. Have a great day.